All right, hello everybody. I just wanted to do a sample for the estimating acceleration project. So after quite some time looking for a good video, I ended up trying it with these 40-yard dashes, these NFL 40-yard dashes. So I had watched a whole bunch of the videos, watching guys run, certainly accelerating, right, starting from rest, ending up with some final velocity, and it takes some amount of time for that change to happen. I watched a lot of videos, and this was a nice side shot. I thought I could make some pretty good estimations, and I felt like this was the one to use. So, just to watch the video, let's just watch John Hightower run.
Mismatches. Sometimes it's going to be in the slot. If you want to, you can line him up in the backfield. And you saw what Deebo Samuel did in the
So there he
postseason.
is. He crossed the 40 yards quite a moment ago. Let me just go back. Oh, that's another guy. Hold on.
And here's Stephen Guidry. That guy where you can get
and John Hightower. This is the guy that I tried. So what I wanted to try to do is really this is a situation where somebody is going from rest, so VI of rest, and then getting to some final velocity. And this does take some amount of time. So definitely accelerating in the direction of that increase in velocity. So I guess I could draw it like this, and then a little arrow, bigger. My motion diagram is what I'm talking about. Got my motion diagram there showing from at rest, velocity increasing over time. I'm accelerating each moment at a time. My velocity arrow then is growing each time. VI, VF. All right, so my scenario is basically I would probably use the definition of acceleration with this one. So I'd probably say A is VF minus VI over time. So if I can figure out I know the initial velocity is zero. If I could figure out get an estimate for final velocity, then I should be able to do a final minus initial divided by time. I should get a good idea of the athlete's acceleration. So basically the VI is no big deal, zero. So the VF. So a few things about YouTube. I did learn that when you pause, you can then use this is me hitting I got to click
matches
on the actual video once again. Now, as I click period, it's going to move forward a frame. So we've already done some calculations on this, and we've learned that every time you hit period, when it's paused, you will go forward one frame, and if you hit comma, you'll go back a frame. So how much is a frame? How much time is that? So we did realize that if you keep track of the time here, and then you click frame by frame using the period, it takes about 30 frames for a second. So it's about 30 frames in a second. So that means one frame, am I on the screen still? One frame equals how many seconds? We'd like to know. So if in 1 second it is 30 frames, 1 second is made up of 30 frames. If you do your math there, you realize that one frame is 0.03 seconds. So then you have some way of figuring out time as you look through the video. So what I wanted to do is I wanted to get an estimate of this final velocity. So how I did an estimate of final velocity is I really just did a velocity is displacement over time calculation. So what I did is I realized after watching the video a bunch of times that it seems they get up to their full speed somewhere around 30 yards, and then they kind of continue at a constant speed. So my idea was to try to figure out what is acceleration of the runner from something like 0 to 35 yards roughly. So what I tried to do then is from the window of the guy running, so John Hightower here, to move it forward a bit, I wanted to figure out, well, how long does it take him to go some distance when I think he's at his top speed? So I can get an idea of what his top speed is. So I move this over to, is this him? Oh, no, I lost him. That's him, John Hightower. So this is what I wanted. I wanted to get, basically what I tried to do is figure out how fast is he going right around here, right around when I think he gets to his top speed. So what I did is I tried to figure out how many clicks does it take to go from what is about 5 yards. Now mine, I can see it's 5 yards. I could do a conversion over to meters there. But if there was something else in the screen where you could make an estimate of distance, that's cool too. So what I did is I tried to do how many frames does it take to go the 5 yards? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, it looks like about 14 frames to go 5 yards. So first thing I did is I turned yards over to meters. That was fun. 5 yards over to meters, and then I'll be able to put in that distance and time. 14 frames, I did the math, so times 0.03 is 0.42 seconds. So if I can figure out what 5 yards is in the metric system, that would be nice. Then I'll know meters per second. So let me just do a quick conversion here and remind you of how to convert here. So yards, I want to get rid of yards, so I put yards down below. I can go to, feet, pretty easy. Then I can go from feet over to inches. I can go from inches over to the metric system. And then I can go centimeters, finally over to meters. Yuck. 3 feet in a yard, 12 inches in a foot, 100 centimeters. 1 inch is 2.54 centimeters, and 1 meter is 100 centimeters. So if you carry out your math there, 4.57 meters. So 4.57 meters. So I just turned my 5 yards over to meters. So really, my estimate for the final velocity is really going to be 4.57 divided by 0.42, and I wrote that down somewhere. So I have what I'm going to call a VF, that speed he gets up to. I had 10.9 meters per second. I didn't know how good that was, how close that was to reality, so I did look up Usain Bolt, and his top speed is somewhere around 12.4 meters per second. So it seemed pretty good. He is the fastest human that we've ever recorded. So it makes sense that he's a little bit more than these NFL athletes. So it seems pretty good. So final velocity. So now I'm ready pretty much to do this calculation here. So I know final velocity, my estimate is 10.9. Initial velocity of 0. So I just need to figure out the time. So I could do that with clicks once again. So I tried to figure out from going all the way back to the start line to the 35 to change velocities from 0 to 10.9. How long does that take? So I ended up clicking along, and finding out that it was about 130 frames for that to happen. 130 frames turns out to be times 0.03, turns out to be 3.9 seconds. And then I was able to finally get my acceleration estimate. So my acceleration estimate turned out to be 2.79 meters per second squared. Looked up Usain Bolt for fun, and he is 3.09 or something, his best acceleration rates. So I feel like, once again, this is good for NFL athletes. So there's my estimation of acceleration. What I was able to do then is, and again, everything is estimating. So I have some actual pretty good numbers here because there's a yardage grid there. But total estimates are completely fine. Just let me know how you found your estimate. As far as the graphs, creating a position time, not super easy. So I just went back to the beginning of the guy's run. Is this him? No, that's the next guy. All right, he's right after this guy.
That guy where you can get.
Okay, so then what I did is I tried to figure out, I clicked forward with my period till it looked like he was about to start running.
Matches.
And then what I tried to do is I tried to figure out about 20 clicks. It looked like he went somewhere. So I did 20 clicks and wrote down he was at like the 2-yard line. Then I did 20 more clicks and saw that he was about the 6-yard line. 20 more clicks, found out he was about the 12-yard line. 20 more clicks, he was at the 19, and I was able basically then to make a quick little position time graph showing my nice acceleration curve. I made a pretty cheap velocity time graph, just kind of put in my initial and then final estimated so I can get a nice diagonal slope here. Slope of the velocity time graph would be your acceleration, and there's my acceleration, 2.79, the slope on the graph here. And that's pretty much it. Then you just got to fill in a few other things. And you need to explain, is your estimate seem too fast or too slow? So I don't know. Mine seems like it's pretty good. If anything, I'm questionable at how I got that final velocity. I kind of calculated it over the 5 yards there. Probably not perfect. But I'm not sure if I'm overestimating or underestimating. I'll have to take a closer look at my numbers and come up with some sort of answer that I'll be able to back up. Anyway, estimating acceleration, hope that helps. And I'll do another one showing a different style, but I'll put that up later. Later.